next video of metals and nonmetals. In this video, let us learn about the formation, definition and properties of ionic bond and ionic compounds. Any matter or substance is made up of chemical bonds. A chemical bond is a force among the atoms in a substance or molecule responsible for the formation of any matter. Now let us understand what happens when metals react with nonmetals. In order to understand this reaction, we are going to take an example of sodium chloride. The elements present in sodium chloride is sodium, which is a metal, and chlorine, which is a non-metal. The electronic configuration of sodium is 281 and that of chlorine is 287. This means in sodium, there are 2 electrons in K shell, 8 electrons in L shell and 1 electron in the valence shell, that is M shell. And in chlorine, again there are 2 electrons in K shell, 8 in the L shell and 7 valence electron in the M shell. Now, do you recall the octet rule? What does the octet rule state? Octet rule states that every atom tend to have 8 valence electron in their valence shell. In order to achieve this 8 electron in the outermost shell, atoms either gain or lose the valence electron. So, for a metal like sodium with 1 valence electron, it can either receive 7 electron or lose the 1 valence electron. But receiving 7 electron requires so much amount of energy that sodium easily follows or attains stability by losing the 1 electron. Similarly, chlorine, in order to lose all the 7 valence electron, so much energy is required to be given to the atom. So, chlorine easily attains stability by accepting 1 electron. Now think, sodium is ready to give 1 electron, chlorine is ready to accept 1 electron. So what will happen if these 2 atoms come close to each other? Yes, you thought it right. So when sodium and chlorine come close to each other, or when sodium and chlorine react with each other, sodium transfers its 1 valence electron to the outermost shell of chlorine. That is, sodium will lose 1 electron and converts to sodium ion with a positive charge. Now the electronic configuration of sodium ion is 2,8. And chlorine, by accepting 1 electron that was lost by sodium, converts to chloride ion with a negative charge. The electronic configuration of chloride ion is 288. This means both the atoms have attained stability by electron transfer method. That is, one of the atom donated its electron to the other atom and both the atoms attained stability. Now when the oppositely charged sodium ion and chloride ion approach each other, they are held together by strong electrostatic force of attraction. The compounds thus formed by transfer of electrons between combining atoms are called ionic compounds or electrovalent compounds. It should be noted that sodium chloride does not exist as molecules but aggregate of oppositely charged ions. The bond between these 2 ions is known as ionic bonding. So let's understand the ionic bond formation. Ionic bond is seen when a metal reacts with a non-metal. In this process, metals lose their valence electron to attain noble gas configuration and converts into a positively charged cation. Non-metals accept electron and gain a negative charge equal to the number of electrons accepted. In this process, both the atoms gain noble gas configuration through electron transfer method. When the transfer of electron occurs, an electrostatic attraction between the 2 ions of opposite charge take place and an ionic bond is formed between the ions. Now let's understand the formation of magnesium chloride, which is also an example for ionic bonding. Magnesium chloride consists of the elements magnesium and chlorine. The configuration of magnesium is 282 and chlorine is 287. So the valency of magnesium is 2 and valency of chlorine is 1. This means magnesium has to release 2 electrons to attain stability. So if magnesium releases 1 electron and chlorine accepts 1 electron, chlorine gains noble gas configuration, but magnesium still has 1 more electron in the valence shell, which makes it unstable. Thus, we need 2 chlorine atoms so that magnesium chloride can be formed. In the formation of magnesium chloride, magnesium atom donates 1 electron each to 2 chlorine atoms. forming magnesium ion with 2 positive charge and 2 chloride ions each with a negative charge. An easier way to represent the ionic bond formation among a metal and non-metal is through electron dot structure. In electron dot structure, we only represent the valence electrons. Here is the electron dot structure of the formation of magnesium chloride. Understand that chlorine is represented only once in the product side, but the number 2 and minus indicates the number of chlorine atoms. The balanced equation for the reaction is Mg gives Mg2 plus 2 electrons, Cl plus 2 electrons gives 2 Cl minus, Mg2 plus 2 Cl minus gives MgCl2. Isn't ionic bond very easy to memorize? In ionic bonding, metals lose electron and form positive ions, non-metals gain electron to form negative ions, and there is a force of attraction between these two ions that results in an electrovalent bond. Okay dear children, here is an homework for you. Try out and check whether you have understood ionic bonding or not. Thank you for watching the video. If you liked the video, hit the like button, share the video among your friends and family, drop your comments, and don't forget to subscribe the channel for more contents of science.